Welcome to the DIY Honda Garage channel. The DTC P0641 code indicates a malfunction related to the sensor reference voltage A circuit in the Honda Civic models from 2011 to 2015. This code is specifically tied to issues with the electrical voltage used by several essential sensors in the vehicle system. The impacted components typically include the MAP, manifold absolute pressure sensor, the output shaft or countershaft speed sensor, the throttle body, and the APP accelerator pedal position sensor. These sensors play a crucial role in managing engine performance, indicating pressure, speed, and throttle input to the engine control module, ECM. The ECM, which interprets signals from these sensors, is responsible for governing the engine's performance and emissions. If the reference voltage from the ECM is not operating correctly, it can throw off the entire system, leading to decreased performance or even stalling. The DTC P0641 specifically implicates a malfunction in the sensor reference voltage A circuit. This malfunction affects several components essential for optimal engine operation, including the MAP sensor, which measures the air intake pressure, the output shaft speed sensor that monitors the rotational speed of the transmission, the throttle body that regulates airflow into the engine, and the APP sensor, crucial for determining how far the accelerator pedal is pressed. These components are located throughout the engine compartment. The MAP sensor is near the intake manifold. The throttle body is situated between the air intake and the engine. The output shaft speed sensor is located near the transmission, and the APP sensor is typically positioned on the accelerator pedal assembly. A failure in reference voltage often means these sensors cannot send accurate readings to the ECM, which monitors and regulates engine performance. Diagnosing DTC P0641 requires an understanding of several possible causes. A faulty sensor, such as the MAP or APP sensor, can directly result in this DTC by failing to provide correct voltage readings. Electrical issues, such as poor connections or loose terminals at crucial components, like the ECM, can also play a significant role in this malfunction. Additionally, a shorted wiring harness affecting the voltage circuit check, VCC, lines could disrupt the flow of electricity between the ECM and the sensors, causing the errors to arise. It's important to methodically explore each of these areas to accurately identify the source of the DTC. Each step builds upon the understanding that the data being relayed to the ECM must be accurate for the engine management system to function properly. When DTC P0641 is present, several symptoms may manifest, impacting overall vehicle performance. Owners may experience engine performance issues, such as a loss of power or decreased fuel efficiency, due to improper sensor readings. In some cases, this malfunction may result in intermittent stalling, where the engine unexpectedly shuts off, increasing the risk for dangerous situations on the road. The check engine light will also illuminate on the dashboard, serving as a warning that the vehicle's diagnostic system has detected a fault. Additionally, the vehicle may exhibit erratic acceleration or hesitation while driving. These symptoms necessitate prompt attention to prevent further damage to the engine or related systems. In the initial troubleshooting step for DTC P0641, the first action is to verify the problem by turning the ignition switch to the on position. It's essential to clear the DTC using the HDS, which stands for Honda Diagnostic System, a tool used to scan and diagnose vehicle issues. After clearing, checking for pending or confirmed DTCs with the HDS will help ascertain if the P0641 code reappears. If the DTC is indicated again, this confirms that the failure is present, and you should move to the next troubleshooting step. If the DTC does not appear, it may suggest an intermittent failure, prompting further investigation into potential poor connections or loose terminals at the ECM and associated components. Moving on to the second troubleshooting step for DTC P0641 involves isolating specific components to determine the source of the fault. After turning the ignition to the lock position, you should proceed to disconnect the connectors from the MAP sensor, output shaft speed sensor, throttle body, and APP sensor. Following this, turn the ignition switch back to the on position to prepare the system for testing. Again, clear the DTC using the HDS and recheck for either pending or confirmed DTCs. If P0641 is indicated at this point, it points towards a likely fault in these components. However, if it is not indicated, it may suggest that the issue lies in other areas that require a deeper investigation, like electrical connections or terminals. During the third step of troubleshooting DTC P0641, you will focus on identifying any shorted parts that may be contributing to the issue. With parts reconnected one at a time, monitor the system by checking for pending or confirmed DTCs with the HDS after each reconnection. When you reconnect a certain part, if DTC P0641 is indicated, it highlights that this specific component is responsible for the fault detected initially. If DTC P0641 isn't indicated, it suggests that you should inspect for poor connections or loose terminals at the ECM and other critical parts like the MAP and APP sensors. This step emphasizes the importance of isolating each component to trace the voltage failure accurately. The fourth troubleshooting step is critical for identifying any potential shorted wiring that could be affecting the VCC lines. Begin by ensuring the ignition switch is in the lock position. Jumping the SCS line with the HDS prepares the system for further diagnostics. Disconnect the ECM connectors A and C, which hold vital connections to the vehicle's electrical system. You will then check for continuity between specified test points and the vehicle's body ground to assess whether the wiring between the sensors and ECM may be compromised. Continuity checks should be done with the connectors in a disconnected state to avoid erroneous readings. If continuity is found, repair the short in the related wiring. If there's no continuity, you might need to update the ECM software or replace it to complete the diagnostics. Upon completing all necessary repairs related to DTC P0641, the final verification step is essential to ensure everything is functioning correctly. First, make sure to reconnect all connectors that were previously disconnected during troubleshooting. Switch the ignition to on and proceed to reset the ECM using the HDS, which refreshes the module's memory in preparation for normal operation. Conduct a recheck for pending or confirmed DTCs using the HDS. If DTC P0641 is indicated again, it suggests that the issue persists and requires a subsequent review of all terminals and connections for possible faults. If the DTC does not appear, the repair process is considered successful, although any other new codes should lead to further diagnosis. Preventive maintenance is crucial to avoid future occurrences of DTC P0641. Regularly checking electrical connections for signs of corrosion or looseness can help prevent issues associated with weak connectivity. Ensuring that all sensor terminals are clean and free of debris is equally important, as dirt can impede electrical flow and cause intermittent signals. Monitoring the functionality of components, like the MAP, APP, and speed sensors on a regular basis will also aid in identifying any developing issues before they escalate into major problems. Consider implementing a routine vehicle inspection that includes scanning for DTCs, which allows early detection and maintaining good vehicle health overall. In conclusion, DTC P0641 indicates a malfunction within the sensor reference voltage A circuit in Honda Civics from 2011 to 2015. This code often stems from faulty sensors, poor electrical connections, or shorted wiring, resulting in various engine performance issues, such as stalling and erratic acceleration. A systematic approach to troubleshooting, starting from verification through to detailed testing of components and wires, is vital for accurately diagnosing the problem. The final repair verification ensures that the fix is effective and sustainable. Preventive maintenance practices, such as regular inspections and ensuring clean terminals, can proactively mitigate similar issues from developing in the future. Understanding these principles equips owners and technicians alike with the information necessary to maintain optimal vehicle functionality. Please like and subscribe to the channel. See you next time.